Hey everyone, my name is Stephanie Gabriel Bukayan and I am with my partner.
Good day, everyone. My name is Jubel Ontoria.
And for the subject of hydrology, our report is about solar radiation and Earth's energy balance. So to start off, the sun. Uh, so the sun has a diameter of 1.39 meters, or should I say 120 times greater than the Earth. So sun is powered by hydrogen fusion. So it is also composed of layers, and the outer layer of the sun is photosphere. And sun's effective black body temperature is about 5,777 Kelvin. So the sun provides life-giving light, such as heat and energy to the earth, and also sun generates space weather. So next we have the solar radiation. So solar radiation, it is called the solar resource or just sunlight, is a general term for the electromagnetic radiation emitted by the sun. So solar radiation, 69% of it is incoming, is also absorbed by the atmosphere and earth. So solar radiation is a radiant electromagnetic energy from the sun. So it provides light and heat for the earth and energy for photosynthesis. So this radiant energy is necessary for the metabolism of the environment and its inhabitants. So the amount of intensity of solar radiation that a location or body of water receives depends on a variety of factors. So these factors include latitude, season, time of day, cloud cover, and altitude. So, but not all radiations emitted from the sun uh, goes to the earth. So much of it is absorbed, reflected, or scattered in the atmosphere. So at the surface, solar energy can be absorbed directly from the sun, and it is called direct radiation, while from light that has been scattered and it's entered the atmosphere, it is called indirect radiation. So the role of the solar radiation is that without the solar radiation, Earth's surface would be about 32 degrees colder. So the solar radiation provides the necessary heat and light for life of Earth. Okay, so what's the role of solar radiation? So it also provides heat, light, and energy necessary for all living organisms. So infrared radiation supplies heat to all habitants on land and in the water. So how does the solar radiation impacted the Earth? So to start off, excuse me for a while. Okay, so to start off, okay, the sun, it has the air surroundings consists of different gases and also some particles. So this layer of air known as the Earth's atmosphere is retained by gravity. So the two main components are nitrogen, which is 78%, and oxygen, which is 21%. So beside containing the oxygen, human beings and other organisms needs to live, the atmosphere has a number of other features such as absorption of ultraviolet radiation from the sun and by the ozone layer and heat retention known as the greenhouse effect. So solar radiation that is not absorbed or reflected by the atmosphere. So, for example, the clouds reaches the surface of the earth. So, the earth absorbs most of the energy reaching its surface, and a small fraction is reflected. So, in total, most 70% of it incoming radiation is absorbed by the atmosphere and the earth's surface, while around 30% is reflected back to the space and does not hit the surface. So the Earth radiates energy and wavelengths much longer than the sun because it is colder. So part of this long wave radiation is absorbed by greenhouse gases which then radiates energy into all directions, so including downwards and thereby trapping heat in the atmosphere. So without this natural greenhouse effect, the Earth's average surface temperature would be an inhospitable negative 18 degrees Celsius, or should I say 0 Fahrenheit. So instead of the 14 degrees Celsius we experience today. So this effect is enhanced by increasing greenhouse gas concentration in the atmosphere due to emissions by human activities such as burning fossil fuels. So the main long-lived greenhouse gases are carbon dioxide, methane, and nitrous oxide. So, but they are not the only forces at work. So for the greenhouse, we have first the water vapor. So water vapor or aqueous vapor is the gaseous phase of Earth. So water vapor is the most abundant greenhouse gas. So it does not stay in the atmosphere for very long, but plays a key role in our climate in its variability and change. So next we have the ozone. So ozone is a high reactive gas composed of three oxygen atoms. So ozone in the lower part of the atmosphere acts as a greenhouse gas and is a major pollutant. So higher up in the stratosphere, the ozone layer absorbs solar ultraviolet violet radiation and affects how much of the sun's heat is radiated back into space. So the ozone layer shields us from the harmful effects of excessive UV radiation, which can lead to sunburn, skin cancer, and eye damage. So next we move on to the aerosol. So aerosol is a suspension of fine solid particles or liquid droplets in air or another gas. So aerosols is the atmosphere also contains small suspended liquid and particles. So aerosols are small dust particles that float in the atmosphere. So they result mostly from chemical reaction between gaseous air pollutant, rising sand, not rising sand, it's rising sand, sea spray, forest fires, agricultural and industrial activities, and vehicle exhaust. So aerosol affect many aspects of human health in the environment. So visible in the case of strong smog or haze events. So you remember yung sa Indonesia na sunog? That is one of example of aerosol. So, kasi may haze yun sa clouds for I think 1 week or so. So, next, also aerosol influence Earth climate both directly by scattering and absorbing sunlight and indirectly. So, by altering the reflectivity of clouds in general, aerosol have a cooling effect on climate, so which partially counterbalance the heat effect of greenhouse gases. So under certain circumstances, however, they may cause additional heating, such as case of black carbon in soot. So the gases and dust particle thrown into the atmosphere during volcanic eruption have influences on climate and cool the planet by shading incoming solar radiation. So the cooling effect can sometimes last for months to years. So next we go to the albedo effect. So it is an expression of the ability of surfaces to reflect sunlight, which is heat from the sun. So snow and ice have high albedo. So much of the sunlight hitting surfaces covered with snow and ice bounces back. So in contrast, dark earthly surfaces have a low albedo. So therefore, they absorb more sunlight. So thus, the proportion of Earth's surface that is covered by ice and snow snow affects how much the sun's solar radiation is absorbed. So, warming the planet or reflected. So, therefore, snow and ice, which are covered in soot from pollution, no longer reflect sunlight, but it absorbs and so melting increases. So the more snow, ice in the Arctic and Antarctic melts, so the more dark surfaces, so the more to have a dark surfaces. So hence to that, the feedback of climate change in the polar region is further warming, so exacerbating climate changes globally. So next we have the sun and water cycle. So the sun is what makes cycle work. So heat causes liquid and frozen water to evaporate into vapor gas, so which rises high in the sky to form clouds. So Earth contains about 1.4 billion uh, kilometer cubes of water. So the ocean holds 1.3 billion of kilometer cubes, and 71 kilometer cubes is fresh water, and of which more than two-thirds is the form of snow or ice. So the sun plays a key role in the hydrological cycle, so constantly evaporating water into the atmosphere. So some of the water is returned as rain, snow, and dew. So part of this precipitation is rapidly evaporating back into the atmosphere. So some drains into lakes and rivers to commence a journey back to the sea. So some infiltrates into soil to sustain groundwater or soil moisture. So under natural conditions, the groundwater gradually works its way back into surface water and makes up the main source of dependable river flow. So plants incorporate some of the soil moistures and groundwater into their tissues. So also it releases some of it into the atmosphere and in the process of transpiration. So the hydrological cycle moves enormous quantities of water about the globe. So all thanks to the energy of the sun. So next we have the solar activity and space water. So it is divided into four main components, which is solar flares, coronal mass ejection, high-speed solar wind, and solar energetic particles. So solar flares impact Earth only when they occur on the side of the sun facing Earth. So over the span of 11 years, the sun activity waxes and wanes as magnetic field lines that are wound and tangled inside the sun periodically break through the surface. So this breakthrough produce sunspot that travels together across the face of the sun. So the heightened magnetic activity associated with sunspots can lead to solar flares, coronal mass ejections, and other far-reaching electromagnetic phenomena that endangers astronauts and damage or disrupt satellites. So a number of national meteorological surveys are developing a space weather forecasting system to meet these challenges. So space weather designates the physical and phenomenological state of the natural space environment, so including the sun and the interplanetary and planetary environments. So the associate disciplines aim at observing, understanding, and predicting the state of the sun. So of the planetary and interplanetary environments and their disturbances. So with particular attention to the potential impact of these disturbances on biological and technological systems. So the effect of space weather can range from damage to satellites arising from charged particles to disruption of power grids on Earth during geomagnetic storms. So radio blackout and transpolar aircraft routes or disturbance of satellite positioning um, system. So space weather monitoring studies that an application are more and more important with the increasing use of space in day-to-day life of telecommunications, so observation and navigation. So Next, we have the Aurora Borealis and Aurora Australis, or it is called Southern Lights and Northern Lights. So, phenomenon that so an aurora is a natural electric phenomenon that creates bright and colorful light display in the sky. So, in the Arctic Circle, they are known as Aurora Borealis or the Northern Lights, while in the Antarctic Circle, they are called Aurora Australis, so, or the Southern Lights and the Northern Lights. So Aurora Borealis or Northern Lights and Aurora Australis are the only visible manifestation of space weather. So energy from the ever-present solar wind or from coronal mass ejection is transferred into the Earth system and ultimately lead to the excitation of oxygen and nitrogen molecules. So, in the upper atmosphere, so when these molecules relax down to lower energy state, they release their energy in the form of light, similar to how neon light works. So, due, the, due to the shape of Earth's magnetic field, the aurora appears in two ovals around Earth magnetic poles as the driving geomagnetic storm intensifies. So, these ovals expand equatorward. So it is in the most extreme geomagnetic storm. So, this can lead to aurora being visible nearly worldwide. So, what is the role of radiation in hydrology? Wait, okay. So, it is the process of evaporation absorb tremendous amount of incoming solar energy through the process of latent heating, energy transferred into atmosphere when the water vapor condensed during the formation of clouds. So, to start, so Earth's energy balance, you will begin by taking an in-depth look of a familiar process known as the water cycle. So, Earth water supply is recycled in continuous process known as the water. So, or such called as hydraulic or cycle water molecules um, continuously move from location to location in this cycle. So, the water cycle is very important to the weather and climate and ultimately to all life on Earth. So how does the radiation, or should I say the cycle of water in hydrology work? So first, sorry, it cannot be played because we were using a PDF. So in the water cycle, it is driven primarily by the energy from the sun. So this solar energy drives the cycle by evaporating from the water, ocean, lakes, river, and even soil. So other waters move from plants to the atmosphere through the process of transpiration. So as liquid waters evaporate or transpires, it forms water vapor and clouds. So where water droplets eventually gain enough mass to fall back to earth as precipitation. So the precipitation then becomes runoff or groundwater, so, and works its way over various time scale back into the surface reservoir. So the water cycle essentially is a closed system, meaning that the volume of water that is in the hydrosphere today is the same amount of water that has always been present in the Earth system. So that's for my report. So we go to Earth's energy balance.
And thank you. His partner Bukayan, for explaining about solar radiation. And so as a civil engineer, we must understand the importance of solar radiation, earth balance. So now I will discussing about Earth's energy balance. So the Earth atmosphere energy balance is achieved as the energy received from the sun balances the energy lost by the Earth back into space. In this way, the Earth maintains a stable average temperature and therefore a stable climate. So sa Tagalog, ang Earth daw is kapag may na-receive na energy from the sun, meron siyang capability na i-balance ito. Merong part ng energy from the sun is mag-reflect para mabalik sa space. At meron din i-absorb ng Earth. Ayan. At ang Earth is may capability na stable yung temperature ng Earth. Ayan. And climate. Next. Ayan. So, 100 units of solar radiation is hits the top of the atmosphere. Surface absorb 51 solar units or 49 reflected and absorbed. Surface absorbs another 96 units from the warm sky. Atmosphere emits 96 units down or warm, but 64 up cold. The surface has to get rid of 147 units, 117 by radiation, 23 by evaporation, and only 7 by rising the air. So this is the process of the solar radiation na pupunta sa Earth. So meron mga units dito na in-explain kung gaano karami yung nare-receive ng Earth at paano ito buwabalik at na-distribute sa bawat aspects tulad ng atmosphere at yung sa climate. Ayan. Next. The job of the atmosphere is to let the energy out. The movement of the air and one's ocean allow energy to be transported to its escape zone. So, makita natin dito sa picture or sa example na merong hot and cold. So, yung hot is piles up into tropics and the cold is escape near poles and aloe. Ayan. Next. Ayan. So, atmosphere is warm from below and energy. So, wait, I will now yung notes. Ayan. So, Earth energy balance describes how the incoming energy from the sun is used in return to space. If incoming and outgoing energy are in balance, the Earth temperature remains constant. So there are three different aspects Earth energy balance. The total solar influx, depending on the distance from the sun, angles, the planet axis, and solar activity. So, sa mga nakita sa picture, diba, sa picture is merong red, yellow, and green. So, sa red side is ito yung heat na ina-absorb. Ibig sabihin sa mga equator, diba? Equator. So, sila yung mga country or mga places na maiinit. At yung yung color blue and green, sila yung medyo less na nare-receive na sunlight or solar radiation or heat from the sun. So, most common sa mga tropical country is mainit, diba? Tulad sa ating Philippines, tulad sa mga Africa. So, nasa side sila sa mga equator. Kaya most directed from the sun. Ayan. And sabi din, mas common yung evaporation sa mga tropical area. And mas common yung rainfall, diba? So makita natin na ang climate natin sa may tropical or sa may equator area is dalawa lang, minsan sunny and rainy. So yan ang effect ng heat from the sun at yung pag-rise ng evaporation sa ocean. Next. Ayan. Ayan. So energy out. So given by combined surface and atmosphere effects decrease with latitude, maxima over subtropical heights, clear air neither absorb or emits much. Minima or tropical continents cold, hot clouds. Whereas from maxima over desert, hot surface, clear atmosphere. So sa mga nakita natin dito sa picture, so ito yung climate or ito yung like satellite video or satellite or solar like radiation feature kung paano nagpo-flow yung heat ng mundo. So sa mga nakita natin na mas common yung red or orange sa mga equator side. So yung Earth meron siyang capability na, di ba, dahil sa air, atmosphere natin at sa ozone is na ano yan, tawag yan na circulate niya yung heat sa mundo. At mas common na mas mainit is yung nasa equator side katulad ng aking sinabi. At meron ding mga energy or from the sun is, 'di ba, is nare-reflect na pumunta sa space. Pero meron ding 50% is na-absorb ng Earth. Katulad sa first slide na sinabi or sa second slide sinabi ko kanina. Ayan, next. Ayan. Energy balance between solar insolation and terrestrial infrared radiation is global, not local. The global balance is maintained by transferring excess heat from the equatorial region towards the pole. So energy in minus energy out. Incoming solar minus outgoing long wave must be balanced by horizontal transport of energy by atmosphere and ocean. So sabi dito na yung heat daw na na-absorb sa equatorial area is nata-transfer palibot hanggang makaabot siya sa North Pole and South Pole. Kaya minsan merong mga day at mga climate na nangyayari na yung sa North Pole and South Pole makaranas din sila ng like mainit na panahon, 'di ba? Minsan naman dahil 'di ba sa climate change is yung mga nagbabago yung yung flow ng heat, minsan mas marami ng heat na napupunta sa North Pole and South Pole kaya natutunaw yung mga ice. Kaya yung earth balance energy, yung heat balance is hindi na nababalance dahil sa climate change and sa mga pollution. Ayan. So next. Ayan. So it takes a lot of energy to evaporate water. And so nakita sa video, medyo blur lang konti. Heat energy taken from the environment and sublimation, melting, and evaporation, liquid water, water vapor, and solid crystal. So katulad sa sinabi ni partner Steph kanina, di ba merong water cycle na nangyayari. So it depends din sa country or sa place kung saan yung nabibase or nangyayari yung water cycle na yan. So merong ibang place sa mundo tulad sa may equatorial area, water cycle nila is, di ba, from the water evaporate and from the clouds, di ba, nangyayari is yung condensation, di ba, nabubuo ng crystal. At meron din ibang part sa mundo is from evaporation and from the clouds is nabubuo yung crystal or minsan na nagiging ice ang yung water na yun. Ayan. So earth balance, energy balance of earth's surface. Ayan. Shortwave solar radiation, long wave infrared radiation, rising, warm, and evaporated water. So ito yung process ng earth energy balance. So meron makareceive tayo ng mga radiation din. And yung sabi dito yung infrared radiation and turbulence. Ayan. So next. Energy from the surface to the air. Energy absorbed at the surface warm the air. Some of this energy is transferred in rising warm thermal, but more of it's hidden in the water vapor. So kapag yung araw is direct na sa Earth is yung mas common na ma-absorb ng heat or mas common na na-absorb ng heat is yung water. So mas common 'di ba is na malaman natin na 'di ba ang Earth is 70% 'di ba is composed by water and 30% land. So mas common na ang uma-absorb ng heat is yung water. Kaya mas common yung water vapor. So mapansin natin na 'di ba yung merong mga wind process or mga weather, 'di ba? Pag malapit na yung December, 'di ba, nagbabago yung wind, yung flow ng wind sa mundo. Minsan naman lumalamig pag December, pag summer naman is nag-iinit kasi yung air from the Pacific Ocean sa mga ocean is nagiging ano siya tawag yan, nagiging horizontal or papunta sa mga sa mga equatorial area. Kaya mainit yung panahon na yan. And kapag December naman, and malapit ng ma-end yung year, so yung air is from, di ba, from North Pole to equatorial. Kaya lumalamig yung weather natin. So katulad din sa picture na ito, medyo blur lang konti. So yan ang isang process. Isa naman yung warm water, di ba? Pag summer, mas mainit So yung air is papunta sa mga lugar is nagiging warm air siya dahil din sa evaporation ng mga ocean. Ayan. Next. Ayan. Temperature lags radiation. Earth's surface temperature is a balance between incoming solar radiation and outgoing terrestrial radiation. Peak temperature lags after peak isolation because surface continues to warm until infrared radiation and exceeds isolation. So, sa picture, ito yung graph kung paano yung napuplow. Ayan. So, yung temperature at yung radiation sa mundo. Ayan. So, medyo blur ng konti. Pero mabasa natin dito, daily temperature. So, minimum radiation, ito, incoming solar energy, itong orange. Ayan. So, tumataas siya. Ayan. So, mas common yung tumataas yung solar radiation kapag mga tanghali. Diba? At bumababa yung solar radiation pag dumadating na sa hapon. Diba? Kung mapansin natin, diba, is yung dati, yung unang panahon, diba, 6 a.m. to 7 a.m., diba, di pa mainit. Diba? Or 8 a.m., di ba siya mainit. Pero ngayon, nagbago na yung flow ng solar radiation. Kahit 6 a.m. pa, 7 a.m., mas umiinit na yung diba, surface. Ibig sabihin, tumataas na yung solar energy na nare-receive. So, tulad ng na-explain ni Steph kanina is yung about yung ozone, di ba? So, yung Earth is meron siyang layer of ozone. Pero ngayon, sa ating panahon ngayon, is nababago na or luminipis na yung ozone. Kaya tumataas na yung absorption ng solar energy, yung radiation or infrared or yung ultraviolet rays. Kaya yung mundo is umiinit na. At yung Earth energy balance is sa mga na-study at na-research namin is ngayon is nagbabago na siya. So, nahirapan na yung Earth na i-balance yung energy na nare-receive from the sun na papunta sa Earth. Dahil sa yung unstable na yung temperature or yung weather dahil sa mga pollution. So, as a civil engineer, so we must understand kung paano nag-flow para sa mga incoming project natin at sa mga incoming gagawin natin na mga experiment. Yan. So, thank you for listening to our report.
Thank you, everyone. And thank you, partner, for the report of the Earth's imbalance. So that would be all for our report in the solar radiation and Earth's energy balance. So I hope you understand well, and God bless.